Welcome back to Matt's Playground. Today, we're going to go over the basics of circles. So I'm going to tell you about um, like the story of the circles and basically about circumference and arc. So we have a few problems. It's not too complicated, just basics. We're not going to have area this time. We'll do it next time. So, our first question, what are arc and circumference? And how did we get the value of pi? So, let's first, I'm going to tell you about circumference and arc, and then we'll go on to pi. So, here is a circle. I'm not too good at those. So, the circumference is um the measure of the outside of the circle, which is basically the perimeter of the circle, but we like to call it the circumference. A circle is a shape made by connecting points from one point, and we connect all the points from the same distance, and we call that a circle. So, an arc is the measure of the distance between two points on the circumference. So the value of pi. This is how the ancient Greeks did it before calculus was invented. So before we go on to pi, I'm going to tell you two basic things. So from one point of the circumference of the circle to the center, if you make a line, it's called the radius. And then when you draw a line right through the middle, crossing the center, that is called a diameter. A diameter is 2 times of the radius. Okay, so on to pi. So let's pretend we're some ancient Greeks and we want to find the value of pi. So if you want to try an experiment, you can get various circular objects. So we're going to measure the distance around the object, which is the circumference. So circumference, we're going to measure that first, and then um, we're going to divide that by the diameter of the object. And that should um approximately be 3.14. Well, whatever. It should be close to 3.14. So now let's get on to some questions about circles. Okay, first question. The circumference of a circle is 32 pi. Find the circle's radius. Okay, I know this sounds super creepy. 32 pi. Like, how are we gonna multiply that? But the truth is, we don't have to. We calculate the circumference by doing 2 pi r, which is equal to pi d, where the radius of the circle is r, and the diameter is d. So over here, d would be 32 because it's by d. So d would be 32, as we did on the first question. The radius is half of the diameter. So the radius would be 32 by 2, which is 16. Ta-da! No having to go into pi. Okay, what's 32 times pi? We're not going to do any of that, just this 2 simple steps. Was it 2? I'm not sure. So, anyway, the length of a 72-degree arc of a circle is 15. What is the circumference of the circle? Okay, so we have this circle. We have these 2 points. Here's A and here's B. So, this is a 72-degree arc. So we need to find the circumference of the circle, right? So if we join this in the middle here, so we know that this is 15, which and the degree measure of a circle is 360 degrees. And the 72-degree arc, thank goodness it gave us that, is 1/5 of 360. So we know that 15 is 1/5 of the circumference of the circle. So let's call that C. So 15 is equal to C by 5. So C is equal to 75. Ta-da! There we go. Next few questions. Okay, next question. Chords A and B, chords A, B, and C, D of circle with center O have the same length. Prove that arc AB is equal to arc CD. So we're gonna start by making a circle, because who can solve this question without making a circle? Well, I guess you could if you have enough imagination, but it's hard to explain it without making one. So, let's make the two things. So we have AB over here and CD over here. So CD and AB. And here is a center O. So let's just start by making these triangles. Okay, so we have 2 triangles, and we know that these 2 are the same. And notice how AO must be equal to CO since they're both radius. Same goes for BO and DO. So we know that these are all equal since they're all radius. So now we know that these angles are also equal. And by that I mean angle AOB is equal to angle COD. So this gives us that arcs AB and CD must be equal because the angles are equal too. We did it! All right, last question. Okay. Arc AC of circle center O has length 12 pi and the circle has radius 18. So let's just draw this out real quick. Here we go. Okay, so here is A, here is C, and this whole part is 12 pi. And we know that the circle has radius 18. Here's our little center O. So we're going to make a triangle. This might help us. Okay, so we have to find OC, which is the radius, and it gives us that radius is 18. So we know that this and this are 18. Now find AOC. So we're gonna start by finding the circumference and finding out what part, like how much part of it is 12 pi. So to find circumference, we're going to use 2 pi r since we know radius, not the diameter. So 2 pi r would give us 36 pi. So 12 pi is 1/3 of 36 pi. So we know that this is 1/3 of the degree measure of the whole circle, which we know is 360 degrees. So this would be 120 degrees. Okay, and our last one, find AC. Okay, so we're gonna start by finding angles OAC and OCA. So, since these two sides are both equal, AO and CO, we know that ACO and CAO must be equal. So we're gonna do 180 minus 120, which is 60, and 60 divided by 2 is 30. So each of these would be 30 degrees. Okay. So then, since this is, since the opposite angle of the side with length 18 is 30 degrees, and 30 is a quarter of 120. We know that 18 must be 1/4 of AC. So 18 is equal to AC by 4. So 18 times 4, that would be 40 plus 36, which is 76. So AC is equal to 76. Yahoo! See you next time. Sorry, I couldn't think of a riddle. I'll try and get one next time. But we might be drawing the area of a circle. Yay! See you later.